Rami Elda, and I did my presentation on the element silver. In Latin, silver is argentum. It's a transition metal located right here. The atomic number is 47, which means it has 47 protons and electrons unless it's oxidized. It has oxidation states of either +1, +2, or +3. And a fun fact there is that oxidized silver actually makes sterling silver, which is in a lot of jewelry that we see today. It has an atomic mass of 107 grams and a melting point of 2,212 degrees Celsius and a melting point of 962 degrees Celsius. Right now, in 2020, it's currently going at a rate of roughly $730 per kilogram and 22 ounces per kilogram. But back in 2002, which is at its lowest, it was going for just $140 per kilogram and $4.70 per ounce. And then here in 2011, at the spike here, it was going for roughly $1,500 per kilogram and almost $50 per ounce, which was the max. Now some of the history behind silver. In 3000 BC, all the way back to 3000 BC, was the first evidence of silver mining, which took place in Turkey and Greece. Moving forward to 1492, Spanish conquistadors started discovering rich veins in South America, which kind of starts to explain what I'll get into a little bit later. In 1500 through 1800, 85% of the silver came from Bolivia, Peru, and Mexico, which are down here, due to the rich veins that they found there. And then in 2018 to 2019, the global physical demand for silver increased from 988 million ounces to 991 million ounces. This increase was due to the electrification and a rebound, or due to vehicle electrification and a rebound in the field of photovoltaics. Mexico, or last year, or between these 2 years, Mexico produced 6,300 tons, which was just under a fourth of the world's total population. And the runner-up was Peru, with roughly a third less at 4,120 tons produced. And then here's a coin found from way back in 3000 BC of silver in a silver mine. Some of the properties, chemical and physical properties of silver. It's a precious metal along with palladium, gold, and platinum. It's got a soft, ductile, and malleable kind of feel to it, and a lustrous white color, which gives it the silverish tint here, or the shining tint. And its high luster and reflectivity of visible light makes it great for jewelry, mirrors, and silverware, and things like this. It's actually the best conductor, followed by copper, then gold. What makes a good conductor is the electricity passed through it must be able to move electrons. The more free electrons in a metal, the greater the conductivity. Silver has a very, very high number of movable atoms, the highest, which makes it, or atoms, electrons, which makes it a good conductor. Some common usages of silver is electrical and coins and metals, which is the top two, followed by plastics, hygiene products, medicine, photography, jewelry, and silverware. You could take a look at the graph here for more information on that. Electrical includes kind of like wiring and pipes, circuit boards, solar panels, novelty explosives, engines, automotive industry, satellites, photography, things like that. But more commonly than not, you'll see copper used in houses because although it's not as good of a conductor, it's much, much cheaper than silver, which is why in things like satellites, you see more silver because it's more important. It's worth the money to insulate the wiring better and electricity better. One of the common usages in the medical field is silvazine, which is silver nitrate plus sulfadazine, which yields silvazine. Here's the chemical equation for it. Silvazine biocide, while sulfadazine serves mostly to keep Ag plus in solution and prevent the light sensitive formation of black colloidal Ag on the skin surface. Again, serious cosmetic problem with AgNO3 based products since patients object to skin blackening. Essentially, what this quote means here is silver is effective against bacteria that are becoming resistant to the overuse of other chemical antibodies or antibiotics. And what silfadazine does, or sulfadazine does, is it contains the silver in the solution, so to avoid the black colloidal from forming due to silver's light sensitivity. But the silver here is keeping the bacteria off of the wound. This is usually used in a cream, silfazine cream, keeping the wound from becoming infected. The image here is an experiment done by Yale. Basically, in each of these, for culture plates, 4 solutions were applied and then seeded with keratinocytes, which are the primary cell found on the epidermis, which is the outermost layer of skin. Those are the cells that grow the harmful bacteria when they become infected, usually due to a burn, because that's most often just the top layer, or at least affects the top layer. As you can see, the silvazine, the purple is a dye. It's called toluidine blue, which is added to show the keratinocytes. And as you can see, silvazine has no dye left because all the keratinocytes have been eliminated, and there's just a little bit left in these ones. Some more medical applications of silver and sulfazine are bandages and the cream, which is silvazine, as well as disinfecting water supplies and the coating of catheters and other devices that you implant within the body. So here's a catheter and then the silvazine. As you can see here, the medical professional is applying the bandage directly to the wound. The bandage has silvazine product on it to treat the infection here, because it'll help get rid of the bacteria. And that's all I got. Thank you very much.